So let's go ahead and start this slideshow on notes for 9.4, the increase in greenhouse gases. All right, so our learning objective for these sets of notes is to identify the threats to human health and the environment posed by an increase in greenhouse gases. And so the first thing that we're going to talk about is why is the sea level rising? So a principle that you learned about in chemistry would explain one reason why the sea level is rising, and that is something called thermal expansion. And you probably already know that as water molecules are heated, they will move further apart. And so, if all the water molecules throughout the ocean are all heated, then and they're all moving slightly apart, this leads to sea level rise. Another thing that is also happening, though, however, is an increase in greenhouse gases because of our when there is this increase in greenhouse gases, so we're putting more methane, more CO2, more chlorofluorocarbons, CFCs, any of those GHGs that we're putting up into the atmosphere, all of that is going to lead to a warmer climate. And even just 1 degree Celsius can cause a massive amount of melting of the continental ice sheets that we particularly find in Antarctica, and then glaciers throughout the Arctic region. And so this fresh water that is stored in these ice sheets and in glaciers then flows into the ocean, and that leads to an overall sea level rise throughout the world. And one thing that I think is important to note is that it's not sea ice that's melting. That does not cause sea level rise. It's the land-based ice sheets and the gigantic glaciers that are at the Arctic regions. So that's what is overall leading to sea level rise, not just sea ice that's melting. And so we can see this graph that is presented by NOAA, NOAA, which is a government agency. And we can see here looking at thermal expansion by adding water. But when we look at both of these, this is the added effect of both of those coming together here. So, and both of those are actually contributing to that. And this is from 1993 running through 2018. And we can see the upward trend, and I'm sure it's still going in the upward direction if we were to draw in a trend line. So, what are the environmental impacts of that? Well, we end up having flooding of coastal ecosystems. So the different estuaries like mangroves and salt marshes that we've learned about during aquatic biomes. So those are going to flood. What that causes is a loss of species also that depends on both the Arctic and the tundra ecosystems. That's one reason we're seeing that polar bears are endangered. We're losing penguins, reindeer that live in the Arctic, all of those organisms. We're also seeing a loss of the thaw-freeze cycle that glaciers go through, and that actually deprives the surrounding ecosystems of a water source. Again, I mentioned previously that this is fresh water that's melting, and so and that runs then into the ocean. And so if we're not seeing this water build up in glaciers on land, then it's not going to be something that runs through rivers then that humans can capture and use as a water source. So here you can see the difference between Muir Glacier in Alaska from August of 1941 to August of 2004. Here's the glacier. You can see it totally covering this area. This entire lake that we now have used to be a glacier. And here where that glacier's gone. And so, what are the human impacts to that? Well, it's going to require human population centers to relocate. So, I'm talking about cities like Charleston, South Carolina, Virginia Beach. Miami, Florida, Tampa, Florida, New Orleans, in Louisiana. All of these have, and especially New Orleans, is going to have it has a very high vulnerability to sea level rise. Florida here in Miami, it's very high. You can see, or it's high, I guess. Charleston, very high. Tampa has got a moderate level of impact or vulnerability. And then Virginia Beach is red, bright red, like New Orleans. So we're going to have to relocate, or we're going to have to come up with some pretty innovative technologies to like flood walls, floating cities. I know that's one thing that Miami's looking at, and probably other areas are as well. We're also going to have an increase in flood frequency, which means folks that live in these coastal communities are going to have much higher insurance costs. They're going to have repair costs. Some just may not be able to afford to have the property loss and be able to rebuild from that. We're also going to be experiencing things like saltwater intrusion. If you recall from Unit 5, that's when saltwater pushes into groundwater sources and it contaminates wells that folks have dug to get their fresh water source. So that's a real problem as well. Now you're taking away someone's drinking water. And it's going to cause climate change refugees, basically, that are going to be forced to move inland to these states and maybe even, leave a coastal state altogether. So that's a real issue. Another issue in terms of humans and human health is that rising climate temperatures causes um, more diseases to be transmitted from human to human or from animal to human. And so, something that I'm thinking of particularly are with these disease vectors are things like malaria, Zika, West Nile virus. Dengue fever, cholera. Mosquitoes are, and ticks and fleas. Usually it's mosquitoes, though, are vectors, which transfer basically they are able to transfer disease to humans, and that can be a real problem. So we'll see higher incidences of these diseases in throughout the world, but particularly here in the US. A warmer temperatures, essentially how this works is that warmer temperatures allow these insect diseases to spread to the parts of the world that they weren't normally able to spread to. And so we aren't used to seeing malaria, Zika, West Nile. These things aren't usually in the United States because we have winters that kill these things off. But if the temperatures continue to increase, then we'll see more of these insects moving in, and then that disease will be able to transfer from animal to human, and then from human to human. And so we'll see that normally these diseases tend to be centralized around the equator, but again, we're finding these in higher longitudes, and they're moving, or higher latitudes, I mean, and they're moving further and further north or south towards the poles. And so that just puts a lot more humans at risk. All right. And so here's the current range of Zika virus, uh, fever, and yellow fever. Here's the current insect range. You can see how red it is along the equator at 0 latitude. And then this is what we're expecting to see in 2080. You can see, especially here in Africa, how that's shifted further south. Let me just go back. Let me see if I can take this slide back a little bit. I don't know if it'll go. I don't always have the best luck with this moving. There we go. There we go. Let me get this out of here. Okay. And so, yeah, you can see this is, let's see if I can get this to pop up again. There you go. You can really see that shifting. It really looked like it shifted further into the southern hemisphere, which is interesting. Okay, so here this is again the new range. This is if we exceed the Paris Agreement goals. And this is just if we keep doing what we're doing right now. Okay, so if we go by the Paris Agreement, um, it's going to relatively stay like it is now. But if we go business as usual right now and continue on this path, you can see that shifting range. So that's an interesting look. Okay, so here we're finally to our practice FRQ for this section. So identify a region where malaria rates may increase by the year 2050. And you've got a graph right here. Let me get rid of my picture again. And then explain how climate change may contribute to this increase in malaria in this region. So if you'd like to do the FRQ, you could pause this now and answer that. And then I'll make sure that I put the answers into OneNote for you. Okay, that's it for the 9.4 notes. Next time, we're going to be looking at global climate change and the impacts on the entire world. I'll see you guys next time.